Okay, so going on to the next example. Okay, this next example is the same on the previous example that we have answered, but the only difference is that in this case, meron na tayong involving na flowing of heat. Okay, so sa thermodynamics kasi it's either yung heat natin is involved or yung heat natin is not involved. No? Sa previous example natin, the reason why wala tayong na-encounter doon na heat, it is because sa problem is sinabi niya doon na closed system, no? Closed system. Nandoon yun siya sa engineering model, no? Na binasa natin kanina. It is closed system. So, pag sinabi mong closed system, the heat that transferred from the gas into its surroundings is not possible, no? So, ibig sabihin, kung yung model natin or yung system natin is being insulated, pag sinabi mong insulated, walang path yung heat ng gas natin para makatravel siya from the gas papunta sa surroundings. Kung wala siyang path, it means that it is closed system. Okay? In here, meron. So, therefore, meron tayong nangyayari na transformation of heat from the gas papunta sa surroundings. Okay? So, yun yung hahanapin natin dito actually sa problem na to. So, sabi dito sa problem, 4/10 kilogram of a certain gas is considered within a piston cylinder assembly. So, the gas undergoes a process for which the pressure-volume relationship is PV raised to the power of 1.5 is equals to constant. So, again, since meron naman tayong relationship between the pressure and volume and then raised to the power of 1.5 is equals to constant, we call this one as polytropic process again. Okay? Once again, pag makakita kayo ng ganitong equation, no, with regards to the process that is being done by the system, okay, so ibig sabihin, tinatawag natin yun siya as polytropic process. Okay? Now, sabi dito, the initial pressure is 3 bar again, no, the same as given sa previous natin, parehas lang naman, no. So, the change in specific internal energy of the gas in the process is U2 minus C1 is equals to negative 55 kilojoule per kilogram. There is no significant change in kinetic or potential energy. So, determine the net heat transfer for the process in kilojoule. Okay? So, in here, no, except for the heat transfer, meron din tayong na-involved dito na internal energies. What do you mean by internal energy? Okay? Except for the two energies that we have already discussed kanina, meron din tayong tinatawag na internal energy. Ano yung internal energy? Yung internal energy is yan yung energy ng isang system in which the particles of the system is being resulted, no? So, yan yung mga energies na na-form ng mga small particles ng systems natin. Okay? Just like atoms, molecules, yun yung mga internal energies na minimin natin dito. So, since in here we are considering the energy, so we have to consider that internal energy, no? And then meron tayong, from your manuals, meron tayong expression for the whole equation of internal energy, including the kinetic energy and then the potential energy and then the change of work. Okay? So, yun. Saka yung heat. Just refer it to your manual. Okay? So, sabi dito, okay, determine the net heat transfer for the process in kilojoule. Okay? So, solution. Okay? So, we have known. Okay? A gas within the piston cylinder assembly undergoes an expansion process for which the pressure-volume relations and the change in the specific internal energy are specified. So, ibig sabihin, meron tayong na-form na change of expansion or change of volume, no? So, ang hinahanap natin dito sa problem na to is to determine the heat transfer, okay, for the process. So, the same, kung makikita natin, no, the process is being illustrated by this pressure volume diagram. So, for state number 1, meron tayong initial pressure, then and then initial volume. For state number 2 naman, meron tayong final pressure, at the same time meron tayong final volume. Okay? So, naka-indicate naman dyan yung mga initial at saka final dito sa problems. No need to discuss that one. Okay? So, dito tayo sa engineering model. Okay? So first engineering model is the gas is a closed system. Again, the gas is a closed system. Then number 2 is the process is described by PV raised to the power of 1.5 is equals to constant, which is also a polyatomic process. And then number 3 is there is no change in the kinetic and potential energy of the system. Take note of that one. Mas wala tayong change of kinetic and potential energy. Okay, so analysis. So for the analysis, we have an energy balance for the closed system taking the form change of kinetic energy plus change of potential energy plus change of internal energy is equals to heat transfer minus work. So ito yung sinasabi ko kanina na equation or the equation including the three energies in the system, or tinatawag natin to siya as energy balance. Okay, energy balance. Okay, nandiyan yan siya sa manual natin, just read it. Okay, itong equation na to, tinatawag natin to siya as energy balance. So ito yung gagamitin natin for us to be able to find the heat transfer. Okay, where the kinetic and potential energy, again, terms drop out because we have already assumed here that it is equal to 0, so 0 0 cancel out. Then writing change of internal energy in terms of specific internal energies, the energy becomes this, no, since sa problem natin kasi is given is yung specific internal energy. So para makuha natin yung actual change of internal energy, we have to multiply it by the mass. Okay, so yun, so we have mass multiplied by change of specific internal energy is equals to Q minus work, in which Q is heat transfer and work is W is work. Okay, so finding Q, so itong work na to is i-transpose na lang natin sa kabilang side. So therefore we have Q is equals heat transfer is equals to mass multiplied by change of internal energy plus work. Okay, so the value of the work for this process is determined in the solution in part A. Okay, so since na itong problem na to is nasolve na natin sa previous examples natin, in which the work being done by the gas is equals to 17.6 kilojoule. So, yan na mismo yung gagamitin natin. The only problem here now is to find the value for internal energies. Okay, the change of internal energy. So now the change of internal energy is just equals to mass multiplied by specific change of internal energies. So it may be equal to, for mass is 0.4 kg, given naman yun siya dito sa problem natin. That is 4/10. So pag sinabing mo 4/10 is 4/10, so that is 0.4 kg multiplied by negative 55 kJ per kilogram. Itong negative 55 kJ per kilogram is yan yung given sa problem natin, the change of specific internal energy. Okay, in which dito yun siya, makikita sa taas sa problem. So calculating that as a whole, so it will result into negative 22 kilojoule. Okay, so since nakuha na natin yung internal energy, change of internal energy, so now we are ready to find the heat transfer. No, only we have to do is to substitute the value, for Q is equals to change of internal energy plus work. So alam na natin yung value nito, alam din natin yung value nito, so we have the only steps that we have to do is to substitute the values. We have negative 22 plus 17.6 is equals to negative 4.4 kilojoule. So this is the final answer for heat transfer.